Imagine you're standing at the edge of a city you've never heard of. It's a warm afternoon on the southern coast of Cuba. You've come down a road that barely appears on most maps, through dense tropical vegetation, to a place that looks, at first, almost normal. Wide boulevards, apartment blocks laid out in orderly rows, a school, a clinic. The architecture is unmistakably Soviet, that flat, functional geometry you'd recognize anywhere, transposed here to a Caribbean island and left to age in the heat and the rain. But the streets are empty. The apartments are empty. There are no children in the schoolyard. And when you walk to the southern edge of the last row of buildings, past the road that leads nowhere now, you see it rising above the tree line, a gray hemisphere, half swallowed by 30 years of tropical vegetation, sitting silent against the sky. That dome was supposed to power an entire nation. By the time they stopped building it, more than $2 billion had been spent. The city had been constructed around it. The reactor vessel was already in place beneath the dome, waiting. And then, almost overnight, the workers left. No ceremony, no final announcement, no organized shutdown, just the cranes stopping, the streets emptying, the jungle growing back. The official explanation is clean and simple. The Soviet Union collapsed, the money dried up, and the project died. Economics. The end. But the deeper you look at Juragua, the less that explanation holds. Because some of the engineers who worked there, the ones who eventually left Cuba and talked, said something that the official version leaves out. They said the collapse came at exactly the right moment. That the plant, if finished and switched on, would have been something very specific. They called it a Caribbean Chernobyl. 90 miles from Florida. This is the story of the Juragua nuclear power plant, the reactor that Cuba built and never switched on. To understand how it ends in a jungle, you need to understand the problem Cuba was trying to solve. By the early 1970s, Cuba was caught in an energy trap. The island had no significant domestic oil production. Everything that powered the country, the electricity, the transportation, the agriculture, ran on imported fuel almost entirely from the Soviet Union. Hundreds of millions of dollars worth each year, transported across the Atlantic on Soviet tankers. It was an arrangement that worked, until it didn't. Castro had been governing long enough to understand the vulnerability. A nation that cannot power itself is a nation that can be brought to its knees, without a single shot being fired. Soviet subsidy was generous. But generosity depends on the giver remaining willing, and nothing in politics is permanent. Nuclear power seemed like the answer. The Soviet Union had been exporting reactor technology to Allied nations for decades. Their VIVER design, the acronym, comes from the Russian term for water-water energetic reactor, was already operating in Bulgaria, Czechoslovakia, East Germany, and Hungary. A single VVR 440 reactor could generate 440 megawatts of electricity. Two reactors working together could cover a substantial share of Cuba's needs. In 1976, after years of negotiation, both governments signed the agreement. The site chosen was near Cienfuegos, a port city on Cuba's southern coast, with access to seawater for cooling, a natural harbor, and enough distance from Havana that the industrial footprint wouldn't become a political problem. Soviet engineers arrived to survey the land. Construction teams followed, and beside the reactor site, they began building a city, not a temporary work camp, a proper city. Wide paved boulevards laid out on a grid. Apartment blocks designed to house thousands of workers and their families for years, not months. A school, a clinic, a cultural center, a transit network connecting the residential areas to the construction zone. The Soviets built this way because the project was designed to last decades. The plan was not one reactor. It was 2 reactors initially, then eventually 4, a nuclear complex that would anchor Cuba's energy independence well into the next century. For a project of that scale, you needed people who would stay, and people who would stay needed somewhere to live. By the mid-1980s, the city of Juragua was largely complete. Thousands of Soviet specialists and Cuban engineers shared those wide boulevards every day. The first reactor was rising from the ground. From the outside, it looked like what it was supposed to be, a massive, apparently progressing construction project. socialist cooperation in concrete and steel. Then, in April 1986, reactor number 4 at the Chernobyl nuclear power plant exploded. What Chernobyl meant for Uruguay is complicated, and the official version of the story leaves out the most important part. The official Soviet position was clear. Chernobyl was an isolated incident caused by a specific reactor type, the RBMK, that was not used in export reactors. The VIR design at sites like Uruguay was fundamentally different, fundamentally safer. The crisis in Ukraine had no bearing on construction in Cuba. Construction continued. But here's the detail the official position carefully omitted. The VVIR 440 being built at Uruguay was the older model, the Model 230. Not the improved Model 213 developed in the late 1970s, specifically to address concerns raised in earlier safety reviews. The Model 230 lacked several features the Model 213 incorporated. A better emergency cooling system, improved containment design, upgraded shutdown systems. This was not a small technical footnote. Several VVIR 440, Model 230 reactors already operating in Eastern Europe would eventually be shut down permanently in the 1990s after Western nuclear experts, finally given access after the Cold War ended, assessed them as insufficiently safe to continue running. The design had known limitations. The improved version existed because engineers had identified those limitations and tried to address them. The reactor being built at Uruguay was the unimproved version. If you want to support this kind of research, hit like now. We go through a lot of records to put these stories together, and it helps more people find them. I've spent time going through the available accounts from engineers who worked at the site, Soviet specialists who later talked to journalists, Cuban engineers who discussed the project publicly after it ended. One detail appeared in multiple accounts, and it's the kind of thing that's easy to overlook until you understand what it means. The reactor pressure vessels, the thick steel containers at the core of the system, designed to hold nuclear fuel and contain the enormous pressures generated during operation, had been manufactured in Czechoslovakia and shipped to Cuba years before they could be installed. While they waited, they were stored outdoors, on site, in a tropical climate, high humidity, salt air from the coast. Temperature cycles that the specifications had never anticipated, because VIVAR reactors were designed for Central European conditions, not the Caribbean. Whether that outdoor storage had compromised the structural integrity of the vessels was a question that engineers at the site flagged. Whether those concerns made it into the formal documentation, past the supervisor level and into the project records, is a different question. The answer appears to be, not fully. Put yourself in the position of a Soviet engineer in 1989. The Soviet Union is visibly struggling. This project represents years of your career. Hundreds of millions have been invested. Your supervisor has staked his professional reputation on it being finished. What do you write in the report? For most of them, the honest answer was, whatever lets the project continue. By 1989, the strain was showing everywhere. Funding from Moscow arrived late, then arrived less. Workers who completed their rotations returned home and weren't replaced on the same timeline. The Cuban engineers, trained alongside Soviet specialists, found themselves managing increasingly large sections of the project alone. And then there was the documentation problem. The complete technical record of the Uruguay project existed primarily in Russian. The Cuban workforce had absorbed a decade of practical knowledge. They knew the procedures, the daily requirements, the routines. But the theoretical foundation, the detailed specifications that told you what material had been used in a specific section of wall, at what pressure a particular weld needed to be tested, what the emergency systems assumed about the state of each component, existed in documents that only the Soviet specialists could fully interpret. When those specialists left, they took the interpretive key with them. This wasn't sabotage. It was the ordinary failure of a system collapsing faster than anyone had planned for. The practical effect was the same. By the time construction stopped in 1992, significant portions of the plant had been built without complete documentation of what had actually been done or whether it matched the original specifications. The Soviet Union dissolved in December 1991. Funding ended. The cranes stopped. The first reactor was approximately 90% complete. What happened next is where the story gets strange. Cuba didn't walk away from the site. They secured it, stationed guards, maintained the city infrastructure, at least in part, and for years, the Cuban government continued looking for a way to finish what had been started. The logic was understandable. The site represented an enormous investment. The reactor hall was there, the dome was there, the vessel was inside, waiting. 90% complete is not the same as 0% complete. In the mid-1990s, they found what looked like a path forward. Russia, as the successor state to the Soviet Union, was willing to consider resuming the project under certain conditions. Cuba would need to secure external financing, bring in international nuclear safety expertise, and agree to a comprehensive inspection of everything already built. The financing was difficult. The inspection was harder. A consortium of international nuclear experts given access to the site in the late 1990s produced assessments that were, in the careful language of technical diplomacy, concerning. The concrete poured years earlier and left exposed to tropical weather showed signs of degradation. Not catastrophic structural failure, but degradation that meant the material was no longer performing to its original specification. The pressure vessels raised questions. So did other components that had spent years in conditions outside their design parameters. And the documentation gaps meant it was often impossible to verify that what had been built matched what had been designed. You could see what was there. You couldn't always confirm it was right. The experts were not unanimous that the plant was beyond repair. Technically, bringing Uruguay to operational safety standards was probably possible. The question was what that would cost. The estimates were striking. Upgrading the plant to modern safety standards, retrofitting, retesting, replacing compromised components, reconstructing the documentation from scratch would cost approximately as much as building an entirely new plant. Here's the take that will probably draw some pushback. The decision to abandon Uruguay permanently wasn't really about economics. The economics were real, but they were an exit ramp from an acknowledgement that neither the Cuban nor the Russian government was prepared to make publicly. The plant, as built, was not safe to operate. Several of the officials involved in those late 1990s assessments have said as much in subsequent years, carefully, in retrospect. Once the political pressure was gone, the collapse of the Soviet Union hadn't killed the project. It had stopped a project that probably should not have been finished. The cost estimates provided a face-saving way to walk away from that conclusion without saying it out loud. Looked at in full, Uruguay wasn't really a Cold War geopolitics story. It was an institutional failure story, a system where every incentive pointed toward continuing, regardless of what the evidence was saying. No single person made the decision to build something unsafe. The design was inherited. Storage conditions were a logistics problem that became a safety problem over years. The documentation gaps accumulated one decision at a time. Each individual choice, in isolation, had a reasonable justification. The outcome was the product of all of them together. In 2000, under sustained American pressure, both on strategic grounds and genuine safety concerns, Cuba and Russia formally agreed to halt the project permanently. Cuba received $500 million in Russian debt relief as part of the arrangement. The Uruguay nuclear power plant was officially closed. The dome stayed. The city stayed, partially. Some apartment blocks built for Soviet workers were repurposed. Cubans with no connection to the nuclear project moved in. The wide boulevard designed to carry engineers to a working reactor became the streets of a different kind of community. Other parts of the city were abandoned entirely. Buildings emptied. The jungle moved back in. The most surprising thing about this story, when you sit with it, isn't the scale of the failure. It's the ordinariness of how it happened. There was no single dramatic moment of decision. No inspection that triggered an immediate halt. No defecting engineer who revealed a secret that changed everything overnight. Just the gradual accumulation of compromises. each one individually defensible, each one making the next a little easier. One detail that stayed with me. In 1986, after Chernobyl, the Cuban government asked Soviet engineers whether the Uruguay reactor was safe. The engineers said yes. They had technical reasons to say so. The VVAR design really was different from the RBMK in meaningful ways. But the deeper question, whether this specific plant with this specific older design, built with equipment stored outside its specifications, in a climate it was never designed for, with documentation gaps already accumulating, that question was asked, answered inadequately, and filed away. And construction continued. Think about this. If the Soviet Union had not dissolved in 1991, the reactor would have been completed, probably in 1993 or 1994, loaded with fuel, started up, 90 miles from Florida. Would it have failed immediately? Probably not. Nuclear engineering has enormous safety margins, and the concerns, while real, were not necessarily fatal on their own. Or it would have operated for years, apparently normally, while damage accumulated invisibly in the concrete, in the pressure vessels, in systems that were never quite built to specification. The kind of damage that only reveals itself when something finally goes wrong. Will the Uruguay site ever be developed again? Comment yes or no. There have been recent discussions about the land, and the answer is less obvious than you'd think. Today, the dome still stands. The jungle has been working on it for more than 30 years. Vines have found the cracks in the concrete. Trees have grown up against the base of the structure. The gray hemisphere that was supposed to contain Cuba's first operating reactor is slowly disappearing back into the landscape that was cleared to build it. The reactor vessel is still inside. No fuel was ever loaded. No power was ever generated. If you want to understand what the end of the Cold War looked like from the inside, skip the speeches and the summits. Look at the physical events left behind, the places where the future simply stopped arriving. Uruguay is one of the clearest examples that exists. A dome in the jungle, a city built for workers who left, and a question the official record has never quite answered. Was this abandoned because the money ran out, or because someone, somewhere, finally understood what it would have meant to switch it on? If this is the kind of story you come back for, subscribe. We cover the gaps, the absences, the places history left behind it without a clean explanation. The next one involves our water and something that still hasn't surfaced.